Here's another video for 7.4 talking about half-angle identities. Here they are. So basically the difference is between cosine and sine is that it's cosine is 1 plus cosine of A inside the square root, and sine is 1 minus cosine of A. And then tangent, you can use any three of those will work. So any three of those work. And basically all you have to find is what is the angle that you're trying to find. So usually these half angles come up when you have like 22.5, 67.5, or like any type of pi eighths, 3 pi eighths, anything that can be rewritten as a half, 0.5. All you have to do is just times these by 2. You times all these by 2, then you'll get your angle A that you're looking for, that A that you're looking to plug in for cosine of A or sine of A for tangent there. This one would be 135, right? This one would be pi fours. This one would be 3 pi fours. Right, so those would be your A's that you're going to use. And then you'd find cosine of 45. You'd find cosine of 135. And then you take 1 minus that, and you'd perform the rest of the identity. So then we can go ahead and practice some of these. There are some other identities in the book that are like sum to product and product to sum identities, but those we don't use as much. You can't use them, but so those are in there too if you want to check those out. But we're not going to do any of those. So here we can do a couple examples. We find cosine of 15. Now might have found this before. So let's go ahead and practice these two examples. Like I said, we've already done cosine of 15. But we were going to do it using a half angle. So basically I just cosine of 15 equals cosine of A over 2. That's a half angle. Right? So since cosines are the same, that means these two have to be the same. So 15 equals A over 2. Multiply by 2 on both sides, and so we get our A. Right, basically that's all you have to do to get your A. Is just whatever they give you multiplied by 2, and that will be your A. So A is 30. So cosine of 15 will equal half angle plus or minus the square root of 1 plus cosine of our A, which is 30 all over 2. So now I use my left hand and look on the cosine of 30, which is root 3 over 2. So root 3 over 2 plus 1. Adding 1 would be 2 over 2, right? And then it's all over 2. Square root plus or minus. So then we get 2 over 2 plus root 3 over 2. The whole thing's over 2, and then it's square rooted. We have a plus and minus. So then we get 2 plus root 3 over 2 over all over 2 square rooted plus or minus. So then when we divide by 2 here, on the second part, that means we're multiplying by 1/2, so we have the numerator here, and then we're timesing by the reciprocal of the denominator, which is 1/2, and so we get 2 plus root 3 over 4, and that's being square rooted, and then we can square root the top, square root the bottom, so we get our final answer, plus minus, plus minus, plus minus. Plus or minus square root of 2 plus root 3 over 2. So there's our answer for cosine of 15 degrees. Okay, so it does look different from your sum formula because it's just a different formula, right? So if I plug this into my calculator and I did plug the one where I used my sum formula, or actually was the difference formula, I would get the same answer. Okay, let's go ahead and do tangent of 22.5. So basically just take your angle that they give you, times it by 2, and it's a 45. So really our A equals 45. And tangent, we could use any of these formulas. So you can use any of them, whichever one you kind of like. Basically, you just can't have a radical in the denominator, right? So we can use any of these formulas that they give us. We can use the second one, sine of A, so that's sine of 45 over 1 plus cosine of A, which is another 45, and because this is a 45, that means we're going to have root 2 over 2, right? So root 2 over 2, and 1 plus root 2 over 2, because those are the sines and cosines. Now this one, the second one, does not have a square root, so the square root right here doesn't have that, right? So we don't need to worry about that, but because we are going to have plus or minus, because we don't, actually we know where 22.5 is. Same thing with cosine 15. We do know where cosine 15 is. That's in the first quadrant, so actually this is going to be positive. Alright, so we actually know this is going to be positive because it's 15 degrees and we know what quadrant that is in. So we can delete all those. Don't have to worry about plus or minus. Okay, back to this one. Okay, and then so then we need a common denominator to add the fractions in our denominator. Okay, so we get root 2 over 2 in the numerator, and then in the denominator we get 2 plus root 2 over 2. Then we go ahead and flip that denominator and multiply instead of dividing. So we multiply by 2 over 2 plus root 2. Now these root 2's cannot cancel because this is a binomial, right? There's two terms here, so it can't cancel that binomial there. Okay, so we can't do that. But we can cancel these 2's here, right? So then we're going to get root 2 over 2 plus root 2. Then we can go ahead and rationalize this. Okay, so then we get 2 root 2 minus 2 all over 4 minus 2. So that simplifies down to 2 root 2 minus 2 over 2. Now, this is a binomial on top. Why I can cancel the 2 now is because in this binomial, this term has a 2, and so does this term has a 2. So basically, I can factor out a 2, and then it will cancel with the 2 on bottom. So that's why I can cancel that binomial with a monomial, because there is a 2 in both of those terms. Alright, so we get our final answer of tangent of 22.5. And since it's in the first quadrant, we know this is positive. Root 2 minus 1. Okay, so here's another example. Dealing with cosine. Cosine of s is given as 2/3. And we're in the, what quadrant are we in? 3/2 over 2 and 2 pi. So s is in the fourth quadrant. We want to find s, the sine of s over 2, cosine of s over 2, and tangent of s over 2. So basically we want to find all 3 of the half angles. So sine of s over 2 would be, and we're in the fourth quadrant, so we know sine is negative. And it's 1 minus our cosine of s. And we've given cosine of s, right? All over 2. So we know this answer of cosine of s. That's 2/3 all over 2. So that is 3 over 3 minus 2/3 all over 2. And so that is 1/3 over 2 square rooted, and it's going to be negative. We can rewrite that as 1/3 times 1/2 square root, and it's negative, and so we get sine of s over 2 is equal to negative square root of 1 over 6. So we get that, and we can go ahead and rationalize that. Root 6 and root 6, and so we get root 6 over 6 is our final answer. We know it's negative because we are in the fourth quadrant. Oh, excuse me, S is in the fourth quadrant. So, actually, if we want to find s over 2, what quadrant that is in, if we divide this by 2, then we can divide these by 2, which is times it by 1/2. Right, so actually it's pi, s over 2 is between pi and 3/4. So that's actually in the second quadrant, and sine is actually positive there. So sine is actually going to be positive because we're looking for s over 2, right? That's our angle's s over 2, not s. So that's how we find what quadrant s over 2 is, the half angle. Okay, now we can do cosine. Cosine is the same exact thing, except we're going to subtract, right? So since it's the same thing and we're going to subtract, can we go, and we know it's in the second quadrant, so this one we do know is going to be negative. So can I jump down to this one right here? Can I jump down to that one and do square root of 3 plus 2 numbers in there, just cosine of s. And so that's going to be 5 over 3 over 2, which is times e by 1/2. So again, we get 1/6, or 5/6 this time. 5/6. It's going to be negative. And so we know that answer rationalized is root 30 over 6. Okay, and we know it's going to be negative because s over 2 is in the second quadrant. Okay, now we can do tangent, and again, tangent, it doesn't really matter which three you do. You can pick any of them, but also since we already found sine and cosine, we could do this. We could take sine of our half angle s over 2 and divide that by cosine of our s over 2, and that would also give us our answer. So cosine is negative root 30 over 6, and sine is root 6 over 6, which equals root 6 over 6 times by negative 6 over root 30. And these can cancel out. These are the same type of roots, so we can actually divide them, right? So we can cancel this out. This 6 becomes a 1, this 30 becomes a 5, so we get negative, because this is negative right here, negative 1 over root 5. If you want to leave it as root 6 over 30, you can reduce it later, right? And then we can rationalize that, so we get negative root 5 over 5. We could also use any one of those three that were given to us. Okay, so here we're just simplifying these. So basically what we want to find is what is our a, right? So here's our a. So a is equal to 12 over x. And which equation is this? Is it sine or cosine? Well, it's cosine. So cosine of a over 2. Right, that's what this equals. Right. And we just said, right, our a is 12, so cosine of 12x over 2. We can simplify that to cosine of 6x, and that's our simplified answer there. This one, as you can see, it doesn't have a square root, so that would automatically be a tangent, right? So tangent, so this is going to be tangent of a over 2. So basically, what is our angle? 5x, so 5x is equal to our a. So we can take tan of 5x over 2. It's just tan of 5x over 2. So there, that one's done. Okay, last example is verifying, right? So we can't multiply both sides by something or anything. You just got to work one side. So we got to rework one side. The more complicated side, this is squared, so that means I'm going to have to square this. I'm going to have to FOIL this out. So sine of x over 2 times sine of x over 2 is sine of x over 2 being squared, right? Not the angles being squared, the sine is being squared. And then sine times cosine is just, it's a positive, so plus sine of x over 2 times cosine of x over 2. And we're going to do that again, right? Cosine times sine the other way, so actually we're going to have two of them. We're going to have two of them there. So we're going to have two of them, and the last one is cosine times cosine, which is a positive cosine squared of x over 2. Alright, so we got that. So now we can go ahead and we can simplify, because let's just go ahead and rewrite this. Sine squared of x over 2 plus cosine squared of x over 2. I'm just reordering this, plus sine plus 2 times sine of x over 2 times cosine of x over 2. Well, this is equal to 1, right? It's equal to 1 because I have the same angle. I just have an angle, right? This is just an angle, this is just an angle. And sine squared of an angle, of any angle, right? Plus cosine squared of any angle, even if it's a half angle, will equal 1. So this equals 1. Okay. And then we can look at our identities and notice that, hey, 1 plus 2 times over 2, or just an angle, right? And that's times by cosine of an angle. Oops, let me rewrite this. So this part, I can take this part right here, just this part right here. It seems like it looks like 2 times sine of an angle times cosine of an angle. Well, that's equal to the double angle of sine, right? That is the double angle of sine. So we can write this double angle of sine, and our angle that we're dealing with is x over 2. So this is just the double angle of sine, and our angle is x over 2. And then 1 plus that, and so the 2's would cancel, so we just get sine x plus 1. And then that's what our other side looks like, right? This side looks like this side. So we're done. Okay, so here we go on page 6, starting on page 688. 51 is actually starting on 689. So you can start with number 51 and start working through these problems, and then you come back and watch the video of how to do them. So we got a half angle, so we have 0.5, so we just times that by 2, we get 135, right? So we're finding sine of 135. And sine of 135 over 2, right, is our angle 67.5, so we're finding a half angle. So it's 1 minus cosine of 135, and we already know cosine of 135 from our example, and that is root 2 over 2, right? But it's a negative because we're in the second quadrant, so it's actually going to be 1 plus root 2 over 2. So really all this work is almost the exact same, right, as we did before. So now it's going to be, and we're 67.5, so we're in the first quadrant, so this is going to be positive. And then we have just 2 over 2 plus root 2 over 2, all over 2. And again, that's inside the square root, that's inside the square root. We have 2 plus root 2 all over 2 divided by 2, which is times by 1/2. So 2 plus root 2 over 2 times by 1/2, which is 4. So that's going to equal square root of 2 plus root 2 over 4, which is going to equal square root of 2 plus root 2 all over 2, because I take the radical on the bottom, right? So that's our answer for their 51. Okay, so a lot of these answers kind of will be the same, right? Just like when you do the left-hand method of finding cosine of 30 is the same as sine of 60, right? So a lot of these answers kind of will look the same. Okay, so tan of 195, so they ask us to use a half angle, right? We don't necessarily have to use a half angle here. We could do, if on a test or something like that, I wouldn't say, okay, you have to use a half angle here. I might give you a hint and say, hey, do a half angle. But you don't have to, right? You could do some formula or something like that, or difference formula. But I want you to do a half angle here. So if we times that by 2, right, then we just have 390, right? So really we're finding tangent of 390, which is just 30 more than 360, right? Because 360 plus 30 is equal to 390. So really we're just finding a 30-degree angle, because so we're in the first quadrant, right? So we're in quadrant 1. So this one, we can use tangent, we can use our half angle, it doesn't matter. Doesn't matter which one we use, we can use any one of these half angles. That's fine. So how about 1 minus cosine of A, and A is, because this is divided by 2, right? So A is 390, because A is on the top, right? So 390, not 195, 390, because I don't know 195, all over 2. And 390 is just really cosine of 30. So really that's just cosine of 30. So we have tan of 390 over 2 equals 1 minus cosine of 30, really. And cosine of 30 is root 3 over 2, all over 2. So you notice these answers are really looking similar, like I said, once again. And so then we get 2 minus root 3 all over 2 divided by 2, which is timesing by 1/2. just going to keep saying the same thing because all these answers will look very odd. That's a 3. Number 2 over 2. Number 2 over 2. Number 3 over 2. 3 over 2 equals 2 minus root 3 all over 4, right? So there's our answer for that. Well, actually, sorry. That is, I'm actually combining some, sorry. This is not divided by 2. This is divided by sine of a. So I need to simplify this. This is actually sine of a. There's my numerator, though. So I do have my numerator done. But the bottom is actually, so this is not divided by 2. Make sure you get my formulas correct, right? Sine of a, which is sine of 390, which is a 30 degrees. So sine of 30 degrees is root 2 over 2. Or sorry, 1/2. So divided by 1/2, divided by 1/2, divided by 1/2, which is the same as timesing by 2, actually, right? Timesing by 2, so those 2's will actually cancel out, and we get 2 minus root 3. So there's our answer, is 2 minus root 3. Sorry about the confusion there. Make sure you get your formulas correct, which ones you're using, right? So that should be good, okay? Okay, so here we go. We're given, we want to find cosine of x over 2. We're given cosine of x is 1/4, and we're x is between 0 and pi half. So if that means if I'm doing the half angle, that means it's going to be smaller than between pi halves, and so that's still going to be 0 over here. That's just going to be pi fourths, right? Because dividing by 2 is the same as multiplying by 1/2, so that's 1/4. So we're just between, we're still in the first quadrant, right? So here, cosine is the square root of plus or minus, but we know we're in the first quadrant, so it's going to be positive plus, so we don't have to worry about that. That's why we just did that work. Okay, it is 1 plus cosine of x, and we've given cosine of x, right, all over 2. So this is equal to the square root of 1 plus 1/4 all over 2, which is the same as adding 1 plus 1/4, right? It's just 1 and 1/4, which is 1.25, right? Or you can change it into fraction form, right? So that's just 5/4. So 5/4, right, divided by 2, which is multiplying by 1/2, so 5/4 multiplied by 1/2 is 5/8, right? So 5/8. So then we can rationalize, and so we get, you take 5/8 and multiply by 8 over 8 on the inside. I'm multiplying on the inside here. So that's where I get square root 40 over square root 64, which is 8 on bottom, so I rationalize that, right? And square root 40 you could break down because this will break down to 2 root 10. 2 root 10 over 8, and that breaks down to square root 10 over 4. And so there's our answer for number 57. So that's done. So here we go. So we want to go backwards here on number 73. And so we're looking at what half angle formula is this. Since we don't have the square root, we know it's tangent, right? And what's the angle that we're doing? The angle is always going to be the same here in both. So the angle is 59.7. So that's the half angle. That's our a, right? So tangent of our a over 2 would be tangent of our a, which is 59.74 over 2. So then we can take 59.74. So 59.74 divided by 2 equals 29.87. So tangent of 29.87. And on 73, that's all they ask you to write, right? Degrees. There you go. So there's your answer. Now we can do number 75. So 75 is looking at the same kind of thing, seeing what formula it comes from. And it is plus or minus 1 plus cosine. So since it's plus cosine all over 2, that means it's going to be cosine of our half angle, and our angle is 18 over x. Alright, so our angle is 18 over x, so that's our angle. So we have cosine of 18x over 2, which is just a 9x, so cosine of 9x, or 9x, 9, yeah, 9x, why did I write 9 over x, 9x. Alright, x, right, because 25, all done. Okay, so we're gonna want to verify here that sine squared of x, a half angle of x, is equal to tan x minus sine x all over 2 times tan x. So we can rewrite this right here as sine of x over 2 squared, right? That's what it means. Then we can rewrite our half angle of sine, which is plus or minus, it doesn't really matter here, 1 minus cosine x over 2, and that is being squared, right? So then the squared and square root cancel out, so we get 1 minus cosine x over 2. So that's as far as I can go that I can see, right? So I'm going to start manipulating this one. Here I don't know quite what to do, so whenever you don't know what to do, always turn everything into sine and cosine. So I can rewrite these two as sine and cosine. So I'm going to take tan of x and rewrite that as sine of x over cosine of x, and that's subtracting by sine of x, and that's divided by 2 times tangent, which is sine of x. So that 2 is in the numerator with that sign there, over cosine of x. Now when you're dividing by a fraction, you're multiplying by the reciprocal, right? Or we could deal with this fraction on top, and we can rewrite this as sine of x over cosine of x, and get a common denominator. So that'd be sine of x times cosine of x, all over cosine, right? I just multiply top and bottom by cosine of x, so I have a common denominator. And that's over 2 sine of x over cosine of x. Now we can go ahead and add those numerators, so then we get sine of x minus sine of x cosine of x, all over cosine of x, divided by 2 times sine of x over cosine of x. And now we can go ahead and flip that bottom one. So we have sine of x over minus sine of x cosine of x. Got my x in there, all over cosine of x. And then we're multiplying that by the denominator, but it's being flipped, so that means that 2 in the sign is going to be on bottom, which is, that's what I want, right? I want that 2 on bottom, because I get that 2 on bottom like the left side. And then on top I have cosine of x, so then these will cancel, right? And then I have sine of x minus sine of x over cosine of x, all over 2 sine of x. Now, you can cancel these sines of x because this is a binomial, right, that has 2 sines of x in it. So really you can factor out a sine of x, so you get 1 minus cosine of x. Hey, that's what I need, right? And then on bottom I have 2 sine of x. So the sine of x will cancel out, and I'll get 1 minus cosine of x over 2, and that's what I need, right? Left hand side equals the right hand side.